What happened? What happens inside your brain while you dream? The secret world inside your sleeping brain. Every night, something extraordinary happens. You close your eyes. The room around you slowly disappears. The sounds of the outside world begin to fade. Your muscles relax. Your breathing slows. And then, without realizing it, you leave reality behind. Within minutes, you enter a world where the impossible becomes ordinary. You can fly without wings, speak to people who no longer exist, visit places you've never been, relive childhood memories that have been buried for decades. Time bends, gravity disappears, the laws of physics no longer matter. Yet somehow, while these impossible stories unfold, your brain believes every second of them until you wake up. Then, almost instantly, the entire world begins to disappear. A dream that felt completely real only moments ago slowly slips away. Faces fade. Places vanish. Conversations dissolve into fragments within minutes. Most of it is gone forever. Why? What is your brain actually doing while you dream? And why would evolution create something so strange? To answer those questions, we first need to understand what happens after you fall asleep. Most people imagine sleep as a simple switch, awake, then asleep. But sleep is not one single state. It is a carefully choreographed journey through multiple stages. Each stage has its own purpose, its own rhythm, its own remarkable biology. As you drift into sleep, your brain begins slowing its activity. The busy electrical patterns of wakefulness gradually become calmer. Your heart rate decreases. Your breathing becomes more regular. Your body temperature begins to fall. This is the beginning of non-REM sleep, a period where the body starts repairing itself. Cells begin rebuilding. Hormones are released. Energy is restored. The immune system quietly gets to work. It may appear that nothing is happening, but beneath the surface, millions of biological processes have already begun. Then, after cycling through deeper stages of sleep, something remarkable happens. Your brain suddenly becomes more active again. In fact, certain regions become almost as active as they are when you're fully awake. Your eyes begin moving rapidly beneath your eyelids. This stage is called REM sleep, rapid eye movement. And it is here that the most vivid dreams usually appear. Imagine watching a city from above at night. During deep sleep, many lights grow dim, traffic slows, the city becomes peaceful. But during REM sleep, certain neighborhoods suddenly burst back to life. Electrical activity spreads across the brain. Signals travel between distant regions. The sleeping brain becomes surprisingly busy. But one question remains. If the brain is so active, why doesn't the body move? After all, if you're running in a dream, why don't your legs actually run? The answer is one of nature's most elegant safety systems. During REM sleep, the brain temporarily reduces the activity of most voluntary muscles. Scientists call this REM atonia. Your body is essentially disconnected from your dreams. It's a remarkable protective mechanism. Without it, people might physically act out every chase, every jump, every fall, every fight they experience while dreaming. For most healthy people, this temporary paralysis ends naturally the moment they wake up. It happens every night, without us ever noticing. Meanwhile, inside the brain, something fascinating is taking shape. Dreams rarely appear as logical stories. Instead, they feel like pieces of different puzzles mixed together. A childhood friend appears inside your current workplace. Your old family home suddenly becomes a spaceship. A conversation begins in your school classroom and ends on the surface of the moon. The strange part is not that dreams are bizarre. The strange part is that they seem completely normal while we're inside them. Why? Part of the answer lies in how different regions of the brain behave during REM sleep. Areas involved in visual imagination become highly active. Emotional centers become extremely engaged. But some regions involved in logical reasoning and critical thinking become less active than they are during wakefulness. In other words, the brain becomes an extraordinary storyteller with a much quieter editor. That's why impossible events often make perfect sense inside a dream. You never stop to question why your childhood dog is talking, or why you're breathing underwater, or why your office is suddenly inside a forest. The dreaming brain accepts these impossible scenes with astonishing confidence. Perhaps the greatest mystery isn't how strange dreams are. It's how effortlessly we believe them. For thousands of years, People searched for supernatural explanations. Some believed dreams were messages from gods. Others believed they predicted the future. Some cultures saw dreams as journeys into another world, a place where the soul traveled while the body rested. Today, science offers a different perspective. Not because dreams have become less mysterious, but because we've learned to observe the sleeping brain itself. Modern brain imaging has revealed that dreaming is not random electrical noise. It is associated with organized patterns of activity across multiple regions of the brain. Exactly why those patterns exist remains one of neuroscience's greatest mysteries. Then there is memory, every single day. Your brain absorbs an astonishing amount of information. Faces, voices, conversations, road signs, music, smells, emotions, thousands upon thousands of tiny experiences. If the brain tried to remember everything equally, it would become overwhelmed. Instead, sleep appears to play an important role in deciding what information is strengthened and what gradually fades. Scientists continue studying exactly how this process works. But many researchers believe sleep helps support learning and memory. Now imagine what happens while those memories are being processed. Pieces of yesterday, last month, and 20 years ago may become active at the same time. Different memories overlap. Different emotions intersect. Fragments combine. Suddenly, your elementary school teacher is standing inside your modern apartment. Your childhood bicycle becomes a race car. Your best friend speaks with your grandfather's voice. The brain isn't trying to create a movie. It's organizing information. And sometimes, organization looks wonderfully chaotic. Dreams also seem deeply connected to emotion. Have you ever noticed that stressful periods of life often bring more intense dreams? Or that joyful experiences sometimes appear in unexpected forms? Researchers believe emotional processing may be one reason dreaming exists. The brain may be revisiting experiences, exploring feelings, making connections, all while you're completely unaware, not replaying reality exactly as it happened, but reshaping it, testing it, viewing it from different angles. Think of a film editor sitting inside a studio. Hours of raw footage cover the floor. Scenes are cut apart, rearranged, combined. Some disappear forever, others become unforgettable. Perhaps, while we sleep, our brain becomes the editor of our lives. But if dreams are helping process memories, why do we forget so many of them? It's one of the greatest paradoxes of sleep. A dream may feel more vivid than reality, more emotional, more unforgettable. Then, within minutes of waking, it slips away, almost as if it never existed. Scientists still debate exactly why dream memories fade so quickly. Some theories suggest the brain enters a unique chemical environment during REM sleep that makes forming lasting memories more difficult. Others believe forgetting dreams may actually help prevent confusion between dreams and real experiences. The answer remains uncertain. Yet nearly everyone has experienced the same strange feeling. You know you dreamed. You know it mattered. You know it felt important. But you can't quite reach it anymore. It's like trying to remember a face hidden behind fog. The harder you chase it, the faster it disappears. Perhaps that mystery is part of dreaming's beauty. Not every story is meant to be remembered. Not every experience is meant to stay. Some exist only for a single night, then vanish before sunrise. As the night continues, your brain cycles through different stages of sleep again and again, each cycle lasting roughly 90 minutes, several times before morning. With each cycle, REM sleep often becomes longer. Dreams may become richer, more detailed, more emotional. The sleeping brain is far more active than most people imagine. While your body rests peacefully beneath the blanket, billions of neurons continue communicating. Signals travel across vast networks. Chemical messengers rise and fall. Memories are revisited. Emotions are reshaped. Connections are strengthened, all hidden beneath closed eyelids. And perhaps that's the strangest truth of all. Sleep looks like stillness. But inside your skull, it is one of the busiest times your brain will ever experience. Every night, without asking permission, your mind creates entire universes, worlds filled with impossible people, impossible places, and impossible stories. Yet all of them are built from pieces of your own life. Fragments of memory, emotion, hope, fear, imagination. The question is no longer whether dreams have meaning. The real question is, why would the brain spend so much energy creating them in the first place? Because in the next part of our journey, we'll discover that dreams may not simply entertain us while we sleep. They may be quietly preparing us for the moment we wake up. Every night, your brain tells a story. Sometimes it's beautiful, sometimes it's terrifying. Sometimes it's so strange that it seems completely meaningless. Yet despite centuries of research, scientists still cannot answer one simple question with complete certainty. Why do we dream? It may seem surprising. We've landed spacecraft on distant planets, mapped the human genome, built machines capable of incredible intelligence. And yet, one of the most familiar experiences in human life remains one of neuroscience's greatest mysteries. What we do know is this: dreaming is not an accident. It is not a malfunction. It is not simply random noise inside the sleeping brain. Dreaming follows recognizable patterns. It appears during specific stages of sleep. It activates particular brain regions, and it has been observed in nearly every culture throughout human history. The real mystery is not whether dreams have a purpose. It's discovering exactly what that purpose might be. One of the oldest scientific ideas is that dreams help organize memory. Think about everything your brain experiences in a single day. Every face, every sound, every word, every decision, every emotion, every mistake, every success. Every second adds another piece to an already enormous collection of memories. If your brain tried to store every detail forever, it would quickly become overwhelmed. Instead, it appears to sort information while you sleep. Some memories grow stronger, others slowly disappear. Important experiences are connected to older knowledge. New skills become more stable. Researchers have found that sleep plays an important role in memory consolidation. Dreams may simply be one visible expression of that hidden process. Imagine cleaning an enormous library. Thousands of books lie scattered across the floor. Some belong together. Some need to be archived. Others can be discarded. From the outside, the room looks chaotic, but underneath the apparent disorder, organization is taking place. Perhaps dreams are what that organization feels like from the inside. Another fascinating theory focuses not on memory, but on emotion. Life constantly challenges us. Stress, fear, joy, grief, love, embarrassment, excitement. Every emotional experience leaves its mark on the brain. Some scientists believe dreams provide a safe environment where those emotions can be processed. Not by replaying reality exactly, but by reshaping it into stories. A difficult conversation becomes a storm. Anxiety becomes being chased through endless streets. Hope becomes flying above the clouds. Loss becomes searching for someone who never appears. The brain speaks a language of symbols rather than facts. Perhaps that is why dreams often feel emotionally true, even when they make no logical sense. Then there is another remarkable idea. What if dreams are simulations? Imagine an ancient human sleeping beside a fire thousands of years ago. Tomorrow might bring predators, storms, conflict, danger. The brain could not wait until morning to prepare. Some researchers have suggested that dreams may allow the brain to rehearse possible situations before they happen. Running from danger, finding shelter, making difficult decisions, practicing survival inside a perfectly safe environment. Even today, many common dreams involve challenges: falling, being lost, being late, being chased, missing an important event. These dreams may not predict the future, but they often revolve around situations that require quick thinking and emotional adaptation. Whether this theory is completely correct remains uncertain, but it reminds us of something fascinating. The dreaming brain is active, not passive. It is doing something. The question is simply what? Then comes one of dreaming's greatest mysteries. Why do we forget so much? You wake up for a few precious seconds. The dream is crystal clear. You remember every detail, every face, every word, every impossible event. Then you brush your teeth, look at your phone, make breakfast, and suddenly, it's gone. Some scientists believe this happens because the brain uses a different chemical balance during REM sleep than it does during wakefulness. Certain chemicals involved in forming long-term memories are present at lower levels during dreaming. As a result, many dreams are never stored as lasting memories. Others suggest forgetting serves an important purpose. Imagine remembering every dream as clearly as every real event. How easily would reality become confused with imagination? Perhaps forgetting protects us, allowing dreams to influence us emotionally, without replacing genuine memories. But occasionally, something extraordinary happens. You realize you're dreaming. The impossible no longer fools you. You look around and think, this isn't real. Yet, the dream continues. This phenomenon is known as lucid dreaming. During a lucid dream, a person becomes aware they are dreaming while remaining asleep. Some people simply observe. Others learn to influence parts of the dream. They choose where to go, what to explore, sometimes even how the story unfolds. Scientists have studied lucid dreaming in sleep laboratories by asking participants to perform specific eye movements after becoming aware inside their dreams. Those eye movements were detected while the dream continued. For the first time, dreamers were able to communicate from inside a dream. It sounded impossible, yet it happened. Then there is another experience that has frightened humans for thousands of years. Sleep paralysis. You wake up, your eyes are open, the room looks real, but your body refuses to move. You try to speak, nothing happens. For a few terrifying moments, you feel trapped. Some people even report sensing another presence nearby. Throughout history, different cultures explain these experiences as demons, spirits, or supernatural visitors. Today, science offers another explanation. Sleep paralysis may occur when the brain awakens before the temporary muscle paralysis of REM sleep has completely ended. Your mind becomes conscious, while your body is still following the rules of dreaming. It usually lasts only a short time. But for those experiencing it, it can feel unforgettable. Perhaps the strangest dreams of all are the ones that return. The same hallway, the same house, the same endless staircase, the same unknown city, again and again, sometimes for years. Researchers are still exploring why recurring dreams happen. Some believe they may reflect unresolved emotional concerns or repeated patterns of thought. Others suggest they simply arise because certain neural pathways become more likely to activate together. Whatever the explanation, they remind us that the brain remembers more than we realize, even while we sleep. As scientists continue exploring dreams, one thing becomes increasingly clear. No single theory explains every dream. Dreaming is likely not one process, but many. Memory, emotion, learning, creativity, problem-solving, imagination. Perhaps dreams emerge from all of them, working together. Consider some of history's greatest discoveries: the periodic table, the sewing machine, famous melodies, scientific ideas. Several creators reported that important insights appeared during sleep or shortly after waking. Dreams may not hand us finished answers, but they may help the brain explore possibilities impossible to see during ordinary waking thought. The sleeping mind is surprisingly creative. It breaks rules, ignores logic, connects ideas that would normally remain separate. Sometimes, that chaos becomes innovation. Perhaps this explains why children often dream more vividly than adults. Their brains are building enormous numbers of new connections every single day. The world itself is still new. Everything becomes material for imagination. As we grow older, our dreams often change, not because imagination disappears, but because our memories, emotions, and experiences become richer and more complex. Then morning arrives. Sunlight enters the room. Your eyes open. Reality slowly returns. The impossible fades away. The people who never existed disappear. The strange cities collapse into fragments. The conversations become whispers. Within minutes, another dream joins the countless others you've already forgotten. And yet, even forgotten dreams may have left something behind. A memory strengthened, an emotion softened, a problem viewed differently, a lesson quietly learned. You may never know exactly what your brain accomplished during the night, because it performs most of its greatest work in silence. Perhaps that is the greatest wonder of all. Every night, while you believe nothing is happening, your brain is rebuilding itself, strengthening connections, sorting memories, processing emotions, creating stories, exploring possibilities, preparing for another day of life. We often think consciousness is where life truly happens. But some of the most remarkable work your brain will ever perform happens while consciousness is temporarily gone. So tonight, when you close your eyes, remember this. You are not simply going to sleep. You are entering one of the last great frontiers of the human mind. A place where science still searches for answers, where imagination and biology become impossible to separate, where memories become stories, where emotions become landscapes, where impossible worlds are built. only to disappear before sunrise. Perhaps dreams were never meant to predict tomorrow. Perhaps they were never messages from another world. Perhaps they are something even more extraordinary. The quiet conversation your brain has with itself every single night for your entire life.